Hello everyone and welcome to AWCI's webinar, Limit Your Liability Series, Part 2. Today we'll be covering practical strategies to prevent water infiltration in stucco assemblies. My name is Tao Wen, AWCI's Education Program Manager. At this time, I'd like to introduce our presenter, Don Pilz. Don is AWCI's Director of Technical Services. He brings more than 37 years of experience in the construction industry as a drywall, lather, building envelope consultant, and product development specialist. As a research and development manager for 17 years, he patented, developed, and successfully launched multiple products now sold across the U.S. Welcome, Don.
Welcome. Thank you for that. You got the intro out of the way so we could jump right into this. So thank you for joining. This is a second part to Limit Your Liability. We're going to go over strategies to prevent water infiltration in stucco systems. So let's start off with the backdrop. So over the years, stucco assemblies have become really overcomplicated. There's a few different reasons for that, but unlike EIFS, which benefits from a single source manufacturing, unified installation details, stucco is far from standardized. When you think about it, there's stucco assemblies involved a lot of different manufacturers supplying different accessories, lath, finishes, flashing, drainage mat, water resistant barriers. On top of that, we've got regional differences and construction practices. The way they build in Florida is going to be different than Arizona and different than the Northwest. So you've got a lot of different ways, regional differences. On top of that, a lot of conflicting opinions with code officials and building envelope consultants. So the key takeaways from today's presentation is we're going to go over the importance of pre-con. Pre-con is really important. It could avoid a lot of problems in the end if you plan for it up front. What's in the code? It's critical that as a builder, you know what's in the code, so it's not used against you. I'll show you that later. And we're going to identify where water infiltration begins. Some key places to look for. If you're a building envelope consultant, you might be aware of some of these, but we'll cover those as well. Drainage plane fundamentals. Now that drainage planes are in the codes, we'll go over some key fundamentals there. And then just overall best practices for risk reduction. That'll be a theme throughout this presentation. So here's what I want you to do. I want you to imagine this scenario here. You're in the middle of a construction defects lawsuit. You're having a meeting with the attorney, and here's your first question. Do you have proof that everything was done correctly and per code? Believe me, if you've ever been in one of those things, construction defects lawsuit, this is what they're going to go over. So documentation is very important. So again, the importance of pre-con. All right, again, like I was saying earlier, stucco systems are complex. When you have multiple trades, multiple manufacturers, weather and sequencing could really impact your schedule. And if you don't have proper coordination, it could really increase missteps and possibly water infiltration. So I've got this checklist we'll go over. And again, don't feel like you have to take pictures of this. You can get the full slide deck after. But one of the things that I would be doing looking into pre-con, I'm going to confirm that the drawings, the specs are ASTM compliant. Now, most of you know about ASTM 1063 and 926. But the new one here that just got codified is C1861. And if you're not familiar with that, that's a standard specification for lath and furring accessories, fasteners for interior, exterior Portland cement plaster. Okay, so it'd be important to get yourself involved to know that one too. Review the control joints, weep screeds, and drainage details. And I always highly recommend, if you can, do a mock-up to confirm constructability. I say confirm constructability because sometimes things look great on paper, and you go to build it and you realize some of the sequencing, some of the steps can't be done. So to get a mock-up to work that through is a good thing. Then verify the framing and the substrate. Now, sometimes you might have a contractor that's already doing the framing for you, and you're the lath and plaster coming in after. In either case, you have to make sure everything's level and plumbed. Got to make sure backing's there, and really ensure that if there's control joints and they're specified on the drawings, make sure you got backing for those as well as your penetrations. And then, of course, with water management, make sure the water resistant barriers are properly lapped and the flashing is worked into the water resistant barrier. We'll go over that later. And then integrate drainage points. We'll go over what that looks like and how important that is. But basically, we want to continue to get the water redirected to the exterior, and you could do that through drainage points. You could also, the lath and accessories, make sure that you're constructing it per approved submittals. Like I said earlier, there's so many different manufacturers out there. What if you're building on the coast and you got to use zinc or vinyl or an upgraded galvanized coating? You want to make sure whatever's being called out is what you're specifying based on your location. The stucco application, again, confirm that you got the proper thickness for the 3-coat, confirm the mix. You find that in ASTM C926, and make sure you document your moist cure. Take photos of that as well. And then the Q&A and QC field coordination. It's really important, since you're dealing with different trades, that you hold pre-construction meetings with the other trades to make sure everybody knows the sequencing and the responsibility so that things are not missed. So that's a general checklist. The reason why we're doing this is we want to avoid construction defects. So what I got on the screen now is from Senate Bill 800. This is for California. Every state's going to be a little different, but I want to point to a couple things. Let's go down to the last final paragraph. It says, even if the damages are suffered or discovered 9 years and 51 weeks after the job is computed, it must still be filed within 10 years of completion. As a contractor, you're on the hook for 10 years. There's one other caveat in there. If there is a problem, you got mold on the interior space, they have to file that suit within 3 years of that being apparent. So those are the two things that you're up against. So you're on the hook for a long time, especially if you're in California. So we're going to look at things to avoid that. One of the things we want to do is identify where the water infiltration is coming from. I had a general rule when I would go out to the fields and I was doing leak detection, and there's specific places that I would be looking at. And I got some of the photos in here. So here, what you see is a flat recessed window. Issues with that already. It should have been sloped. However, once you pull everything back, you see that the self-adhered flashing stuck in certain areas and certain areas not too good. On top of that, they use a perforated casing bead. And as you could see, where you know from this, water can get in through those holes. Same thing here. I mean, we've got a short flange casing bead right here. We got paper right here. That could just wrap around. Now it comes down and it got into the exterior. You can see the damage down here in the sheathing. I'd always be looking for head flashings. Here, right here, you see no flashing here. They attempted to do some sealant right here across the top. You can see it's already separated, but again, no flashing there, so you'd be looking for that. Missed fasteners. You could see them right here, that the fasteners were missed here, and that'll definitely lead to some water infiltration down the line. Over here, now this might not seem like a big deal right here, that you've got this hole. You've seen it before, where you've got a foam plant on and somebody might take a nail, drive it in there to hold the foam plant on until that adhesive holds up, right? Here's the issue with that. This is that same job. We pulled everything off, and this nail right here is what caused all this damage here. Just from that one nail hole. Just from that one nail hold in that, created all that dry rot that you see there. So other ways here. Now, I know this is an exaggerated picture right here. Okay, I'm showing damaged water resistant barrier. The reason why I'm showing this is we had one project down in the town that I live in that halfway through the project, the contractor went bankrupt and it sat there for a year. The water resistant barrier was getting exposed that entire time. Now, I don't know if they came back and fixed it or not, but that is one thing that you want to watch for. And a good consultant, building envelope consultant, will mark that and look for that later on. So you want to make sure you're going over good water resistant barrier. And then, all right, so we're talking about stucco cracks here. I'm going to address those. Stucco could separate from aluminum reveals like you see there. You get cracks there. This was substrate removal, and that was creating some of these cracks as well. All right, but here's the things that I want to talk about that. Cracking can happen. During the curing process, stucco could crack as it cures. Cracks can telegraph through the substrate like we've seen in that last image, especially if the substrate's able to move. Cracks can happen along the trim, like I just showed especially with aluminum. And if it's improperly mixed, I've seen jobs where they've had a lot of cracking. They'll take a sample of that stucco, they'll bring it down to a lab, and they'll try to see if you properly mixed it. It's never really a strong believer in that you can break it down that much, but I'm just saying some of the things you'd be up against, and they'll try to say that you have the wrong mix. Sudden or drastic changes in the stucco thickness can cause cracking too. We'll talk a little bit about that. One area will that happen if you've got a lot of buildup with your flashing, and then after the flashing's gone and you got regular water resistant barrier, there could be a step sometimes. That could cause cracking. So the fact of the matter that stucco cracks is not the main problem, but it is essential to reduce the likelihoods of cracks. I just want to say, because you're never going to eliminate them altogether because stucco is cementitious and therefore it's going to crack. So here's some tips on how to minimize cracking. Okay, so first off, you want to go per the code. In the code, it'll say that you got to put control joints in ASTM 1063, basically every 144 square feet. Different things for that, though. There's different ways to do that. So you might want to do them off the corner of a window. You might have a different pattern that you want to do, but keep in mind that you're going to have to put them in. Generally, it's every 144 square feet. Add an expansion joint at your floor line. Now you might be thinking, okay, if I've got a load-bearing building that's 5 stories tall, do I really need to have an expansion joint with movement? It's going to do 2 things for you, though. It's going to break up that panel. So instead of that full panel being, let's say, 60 feet tall by 100 feet long, continuous stucco, what an expansion joint will do at that floor line is break up that panel. Now maybe it's 10 feet by 50 feet. Instead of being 50 feet by 50 feet. So you break it up, and that will help reduce cracking as well. Again, make sure that the substrate is properly installed. Make sure that that substrate can't move and that it's flat. Keep something in mind. In construction defects, if you cover it up, you bought it. Your time to say something is before you cover it up. If you don't like something, say something. Install the lath correctly. Make sure you got the proper fasteners, proper overlapping. This will help minimize cracking. Follow the mix standard. You could find it in ASTM C926 or with the manufacturer's mix guidelines. Make sure that you're mixing it correctly in the proper thickness. Control that control joint. I've seen this a lot, okay? I always recommend to contractors to take photo documentation of your moist cure. If a building does crack, that consultant is just going to assume that you did not do any moist cure, and it's going to be up to you to prove it. So take photo documentation. You can prove that. Plan for weather. Don't ever let a GC say, oh, it's got to be done by this date. You go and do it, and maybe it's too hot, too windy, something happens, and at the end, if you try to go back and say, well, they made me do it because of X, Y, and Z, you're always going to take responsibility at the builder because they'll always say the builder should know better. So moving on to expansion joints and control joints. Now, there was a time not too long ago where in ASTM 1063, that expansion joints and control joints were listed as the same thing. They are not. Control joints are basically screed points to make the work area smaller, but they also will aid in limited movement during the curing process. So control joints are stuff like 15s, number 30s, solid leg 15, double Vs, double Js, mid-wall screed. Those are all types of control joints. They're single piece. Get to expansion joint, that's a 2-piece accessory, and it does provide movement between separate panels, especially floor lines. Just keep in mind, control joints are not expansion joints. They both have separate functions. Very critical here is that keep in mind, aluminum channel reveals are not control joints. They're not considered control joints. Why? Because they're rigid, and stucco will expand and contract at a different rate, and this will remain rigid. Therefore, you'll see a lot where the stucco pulls away. This one pulled away so much, it pulled away right here in the center. So you might be thinking, what's the fix? This is the fix. Not too pretty looking. This was a job in the Bay Area. It was a hospital, and before the hospital interior were completed, I think they counted up 400 separate leaks. They found out it was coming through here, so this is what they did. They routed the stucco out here, they filled it in with a sealant, and they put an elastomeric coating on it, and 1, 2, 3 tape over all of these. Again, not a pretty look, but that's what they had to do. Earlier, I was saying that sometimes you get a crack when this, the stucco thickness changes. Well, what do you think is in line with this crack right here? This is the flange, a nailing flange for your reveal. And sometimes if you got a shim underneath this, now you've got maybe 7/8 stucco here, but back to the water resistant barrier, you might have 1 1/8 1.25 inches, and therefore you get cracks like this. Remember, they're not control joints. But I'm not going to just single out aluminum reveals. I'm now going to talk about control joints. So you might look at this one right here and look at the damage. This is a regular double V control joint. This was a project we were working on. It's about 30 feet high by about 40 feet long. no windows, just control joints. We had water showing up at the bottom. So we went in and cut out this intersection right here. And this is what we found after a water test. When you pull it back, it completely ate away the paper right there, got to the substrate and went all the way down. So that was an issue there. Here's another project here. So this was only after 1 year. This is damage after 1 year. And what happened, this wall was a little bit bigger, maybe about 50 feet tall, maybe 20 feet wide. And all we had was a horizontal control joint, double V, every 10 feet or so. Done the water test, I'd get up to the 3rd floor, I'd find it on the 1st floor. Next day started again, got up just a little bit past the 2nd floor, and now I got water on the 1st floor. Again, that's not telling me much of anything. So I had to go chip it out. And this is what I found. This would be the line of that control joint. All right, and this would happen when I pulled it all the way back. Got a little rust there on the lath. You got some rusting here on the nail and some water damage here on the board. So we knew that this was coming from the horizontal control joint. What we found out is that because the water resistant barrier was going completely behind, let me see if I can draw this up a little bit. It was just going behind. That means that the water was going behind the control joint all the way down, and it was deteriorating at every level. So every level was allowing a little bit of water to come in, and it all migrated down to the bottom, and the water was only showing up on the 1st floor. So the fix was this, what you see here. So if you look at this, the first is the paper right here, paper here, then the control joint with a solid flange here. This went over the top. And then there was a peel and stick that went over the top of that. And then again, water resistant barrier over the top of that. What does that do? It forces all water out right there. So that's what we did for the fix. And we did that all the way up and we had no more leak. And this has a solid flange here so that you could use a self-adhesive flashing on here and properly lap that out. So that was a fix. There's other ways of doing this. Let's say that you had a drainage mat. Now, you'll notice that a lot of these double J's, double V's, they'll be typically done in a 3/4, 7/8, 3/8. They'll do all those standard sizes. But once you get into where you've got a drainage mat here, now this ground is going to be thicker. Well, you'll have to find something else that will allow for that thickness so that you get your flange all the way back to the sheathing back here. Now, if you see, everything is lapped, everything is properly shiplapped in here. So when water comes down this drainage mat, it's going to do 2 things. It's going to drop out these holes or it's going to drop out here. So there's 2 areas for that to drop out. What we're trying to avoid is any water from here getting down into here. And we do that by forcing all that water out right at that drainage point, what we're calling a drainage point. Okay, a few different ways to do this. Here's another way. You could do it with vinyl. All right, again, this panel here, separate from this panel here, and all this water is going to come here. It's going to come out. Okay, so that's a really good way to do that, to keep that water out, keep the panels separate. And again, this is just another side view of this so you could see all the lapping. So here you got your water resistant barrier here. You got your self-adhered flashing here. You incorporate your stucco accessory with the flashing here, peel and stick here, paper, water resistant barrier drainage mat, focus on getting them out of those holes, and you're out. Again, we're breaking up panels. We're reducing the amount of bulk water that could get into this system. So this is a picture of that job that I was showing you where we saw the damage to the lath and to the control joint there. Now imagine if we had drainage points here. So that means if I had a leak up here, what would happen is I'd force the water out right here. Force it out right here. What was happening on that job is I'd get a little bit of water built up here, built up here, built up here, built up here, and now I got mold. I got all the accumulation of the water down on the ground floor. But if I could break it all up with drainage points, then I could eliminate the amount of water that gets in there. More importantly, let's say that I had a big awning up on the top. There's an awning up here, and they didn't properly seal that awning where it bolted back into the to the substrate, and I got water going in right there. If I've got drainage points, I could just have damage in that one panel instead of having all that damage all the way down. So I could make it all separate, compartmentalize it by keeping my panels separate. All right, so what does the code say about flashing? This was a big thing that I learned still while I was in the trade, and I don't think too many people in the trade know the complications of this flashing. I think a lot of consultants out there love this wording, and I just want to cover it with you real quick. So I'm taking this from the 2021, requires water WRBs behind stucco flashings. Here's a key word: flashing must be installed to prevent water intrusion at openings and terminations. So that's where they're kicking in that word flashing in section 2510. But they go back and do it again in chapter 14. And it says here to prevent moisture from entering the wall and redirect, that's a key word, redirect the water to the exterior. So they're talking about flashings in the code. This is why it's important to know the flashing and what flashings are. Well, flashings can be done by other trades. You know, take for instance this roof flashing. All right, you want to make sure that's all installed before you come in and do the lath and plaster around it. This is great flashing. This was done by a sheet metal, obviously a sheet metal contractor, probably in the drawings. That's great. Window head flashing, kick out flashing, very important, typically done by the roofer as well. But notice that all of this flashing is integrated into the stucco. That's why I'm pointing it all out. You even got peel and stick. Now, we could argue if that's a proper way to do it, but what I want to bring up is this right here. Anytime you have a penetration, whether it's a wire, it's a conduit, it's a plumbing pipe, it's great to have these types of flashings around it, because you'd be surprised, a little hole like that that's not properly lapped can't allow water into the system. So make sure even this stuff is properly flashed. When they're talking about this, they're also talking about properly flashing into the water resistant barrier. This is just an example of that. I got my water resistant barrier, and now I'm going into my window flashing. So everything has to work together to redirect that water to the outside. Sometimes you might see recessed windows with a lot of peel and stick flashing in there. Maybe there's a waterproofer that is doing this for you. So this is, again, comes back to the coordination. If that's something that's got to be coordinated, let them go first. And then you could also have liquid applied, which we have out here, and we could have some self-adhered flashing. So there's different ways to do it. My recommendation, though, is to keep it simple. Okay, more is not necessarily better. Too many layers can cause a lot of buildup and overcomplicating the details. Now, I'm not saying that this won't work. All I'm trying to point out is look at all the little steps. When I was still in the trade and I would see some details like this, I would know that there's maybe 2 or 3 guys on the job that could properly do this. So if you could try to make the details more simpler, again, I'm not ripping on this because this could work. But when we start getting into all this origami, this is what leads to a lot of problems. So overcomplicated details can also lead to missteps in workmanship. All right, I'm going back to this one more time because I have a little story on this. So in 2004, the company that I was working for was in a construction defects lawsuit, and I was the foreman on the project. It was a warehouse that had these large windows in there, and there was leaks, water infiltration coming from these windows. I was convinced that we didn't do anything wrong. I encouraged our company I was working for to not give in, not to cave, and it ended up going to trial, which doesn't typically happen in construction defects cases, but it did in this one, and I had to take the stand. And I was nervous. The lawyer could see that I was nervous. So the lawyer started asking me real simple questions like, what's a stucco accessory? And then they started asking me all these easy questions. And then they circled back and said, okay, so the water was coming through the windowsill. Now that was well documented. Everybody knew that. I said, yes, the water was coming through the windowsill. And he said, okay, and what was that stucco accessory that you used at the window? I said, I used a short flange casing bead on that. He goes, tell me, why didn't the casing bead redirect the water to the exterior? And I kind of cockily said, confidence, I said, because it's not flashing. He goes, oh, so it let the water in. That's exactly what happened. I walked right into it. He took this part of the code and used it to his benefit, and it was the right thing. Flashing is supposed to redirect the water to the exterior. So think about it. Even your stucco accessories should redirect the water to the exterior. There's a lot of different ways you could do this. So I've got a few designs up here. Again, what we've got is a window head flashing out here. And then we've got a weep screen. That could be done with 2 pieces. It could be done with 1 piece. But one key thing to this is if you're using a drainage mat here, you want to make sure that drainage mat is going to feed into an exit. Now, look at it this way. You got a stucco assembly. You're going to have cracks here and there. You're going to get some water in there. Getting water in there is okay. Incidental water is absolutely okay.
That's what you got a water resistant barrier for there. But you want to make sure of one other thing. You want to make sure your exits are wide open. You're going to get incidental water, but if you close up or you restrict your exit points, you're going to get a lot more water in there, and that's going to lead to some damage. So as we go through this, I want you to look at it as exits. Like everything that we're going to, water's in there, our exit doors open. So we just showed that one. That one is, again, this is what we're talking about. We're going to get it out. We're going to feed it right into an exit point, and then it's going to go out. There's no ways for stucco to clog up those holes because the holes are back right where the water is going to drop off into. Again, the thing here is redirecting the water to the exterior. Okay, when you've got different claddings, all right, so down here I got a brick cladding, up here I got a stucco cladding. We do not want the water that's behind the stucco cladding to go directly behind where the brick is. We want to kick it out. So that's what we're doing here. All the water in the stucco is going to come down here, kick out over that flashing and get out. Here's a better picture of it. So again, our bricks down here, yes, we have a water resistant barrier here. We've got our flashing here. But we're going to counter flash everything into this and out through here. Okay, so we're not allowing water that's up here to get down into here. Okay, same thing here. So you got these open air slots. Open air slots can allow air in and water out, redirecting water to the other side. All right, let's talk about expansion joints here for a minute too. All right, so expansion joints here, you have different types. A lot of them, you'll have this flange right here, okay? Now what happens with that flange is if I've got an acrylic finish coming over this and it seals up to that flange, now my water that's coming down is trapped. I just closed off my exit door. Well, where's that water going to go to? Typically, it's going to feed around that water-resistant barrier and start working its way back up. So what we want to do is, again, open those exit doors. Here's our exit door here. Here's our exit door here. There's no way to trap this in. So when you're looking at expansion joints, here's another illustration of it. So I took this from a consultant that had written this years ago. And what they were saying is, okay, if you're going to use a number 40, we're going to recommend sealant right here. I'm not a real big fan of sealant because it requires maintenance. The other thing that I don't like about this is you've got perforations. Perforations, and anytime you have a perforation, if water gets around there, it gets exposed to that perforation, water could get inside of it. We don't want that. You notice no matter which direction I put this number 40 in, I've always got this little area that could fill up with water right down in here. And I want to avoid that. So again, running the pencil test, you want to look at that. You want to make sure water is always free to get out, because if you put an acrylic finish over the top of this right here, you're going to seal that up pretty good, and it's going to be slow to get out. All right, soffit corners. This is another area that I would look to a lot in construction defects too. All right, so over here on the left, let's just say we use a corner reinforcement right here. And now I've got my water coming down here. I can't get it out, so what's going to happen? It's going to track back here. And eventually it'll come out, but it's going to cause some damage. We always want to keep this panel separate from this panel, okay? You don't want that water to be able to bypass that and to be able to get over into that soffit. Here's another way of looking at that. Okay, this is another one. So this was a project that I was working on. And what happened on this project is that this was a parapet wall up here. So what happened on this one project was that water, the water over here, there's a window over here. I was spraying water over here, and I was getting water over the top of the window on the interior side. I couldn't figure out why that was happening. What happened is this water was coming down here. This was a foam band, couldn't get out, so it starts tracking back, and it eventually dropped over that window. So again, back to my point, you always want to keep these panels separate. So what do we got over here? We've got a panel here. This is separate from this over here. This water is going to come out and exit. It can't get back over to that corner. So that's when you're ever designing your soffits, keep that in mind. Here's another way to do that. Again, this panel here is separate from this panel here. Water comes down, you get in these holes, and it can get out. So that's what you want to look for in a soffit design. Even if you've got aluminum here, okay, this is another good one that will work because there's no capture flange right here. So what's going to happen is that water is just going to drop out here. And again, this is separate than this. So that's key in soffits. Now, there's an old accessory called the number 5, generically called the number 5, and it had these big holes in it. Some of you may remember that one. Now, those were keyholes. Back in the day, they wanted the stucco to go into those keyholes and hold that stucco closer to that stucco accessory. Now, that's back when everything was cement, your scratch, your base, and your finish coats. But once you started getting acrylic finish introduced to stucco, something else happened. Now, that acrylic finish could come down and it could seal up over here. Now the water would go into there, and now it's coming back here and it could become trapped. That was an issue with that accessory. So taking these holes out is one key way of not having that happen. Okay, and this was a photo of what that looks like. Again, they used a reinforced corner here. You don't see a soffit drip on there. Not a lot of water. This isn't that big of a panel, right? But look at it, eventually made its way out, but it cracked all along here. So if you had some place where the water could escape out in this corner, you would avoid that altogether. Specify non-perforated extended capture flanges. Okay, so this was a project I was working on. I was able to take my 2 fingers and actually pull this off, pull it right off. It wasn't bonded here. It wasn't bonded there at all. The finish went over the top of that. The sealant stuck to the finish, not to the metal, and I was able to pull that out. Water easily got in there. So again, here I'm going to have a bigger flange here, and you got the metal up here. Now I could get a proper sealant joint in there. Also, no holes in there, and I'll show you why that's important here. So let's say I had the paper just wrapped around right into this corner right here, and I cut that paper a little short. I've got holes here. If I got holes there, water could get right in there, right there. So that's an easy fix, but you can see how that was commonly done before. So here's a different way of doing that. So here we got a flange that doesn't have any holes in it, but what I'm doing is I'm taking the self-adhered flashing and I'm putting it over this leg, and I'm going to put it over the paper right here. Okay, so I'm going to prevent any water to be able to get over here. This is all sealed up, and then I'm not going to get any finish on this right here, and I'm going to have my sealant go right to the metal edge. Now that's sealed. You're going to reduce, what we're trying to do is reduce the amount of water that could get in there. All right, so again, this is just another illustration. I've seen this happen quite a bit where, again, with the capture flange, this is a weep screed. This is why I never recommend a casing bead, a type of a weep that I have a capture flange right there. We don't want to have that because, again, the acrylic finish could go over that. Now I created this bathtub effect, and that water will start building up. And then what can happen, you could get behind the paper, and now it's going to overlap that flange, and now you got it to the interior side. So again, this really started happening when elastomeric and acrylic finish coats were introduced to it. So keep that in mind. If you got a weep, you always want to have a sloped edge there. Again, this is what it might look like. And I know those who could tell about stucco, that's not an acrylic finish. I realize that. I'm just showing the image of what happens sometimes when you've got too much water in there and you have that staining. It's because water, my exit doors are blocked, basically. All right, so picture this now. And I'm going to say this out loud again because I was a building envelope consultant. I'll say this out loud. Many building envelope consultants rely heavily upon ASTM standards to find fault with the contractor and to point blame. I know it's kind of brutal to say, but there is truth to that, even if it's not directly contributed to the water intrusion. So this is why contractors are held to a much higher standard of how things are to be built. So, question for you. If control joints are not shown on the exterior elevation and the contractor does not put them in and the stucco cracks, now you got some consultant out there, who's going to assume the responsibility for no control joints? For most of you guys know that answer, it's going to come right back to the contractor. Okay, so what do you do if you're the contractor? You want to limit your liability with control joints. What do you do? Here's 3 different options. Okay, the first one, a little rough, a little aggressive. You can RFI and refuse to proceed until the architect gives clear direction. So nope, I'm stopping until you tell us what to do. A little softer approach. You can notify the architect that control joints are required by code and their placement must be specified. Bring it up with the architect. Or if you've got a really good working relationship with everybody, you could provide the architect with suggested control joint locations. But the most important part, if you're going to do that, you have to request a revised elevation drawing from the architect indicating the placement of the control joints. Do not assume responsibility for that. Let them know what might be a good spot, but let them draw back in. Other code changes. So 2024 International Building Code and the Residential Code, the change we're talking about here is regarding drainage mat. Now in 24, there was a significant update where and what they did is they took away the phrase where applied over wood-based sheathing. Okay, so now it's basically saying all types of sheathing that receive stucco cladding are going to have to comply with this new drainage mat requirements. Okay, so if you look at it, these are the sections here I've got for you. 2510.6. This is where they're going to talk about the water resistant barrier. Notice something that's very, very intentional. It says required also in 1403. Remember that 1403, we're talking about flashing there. So they're always integrating flashing with water resistant barrier with a drainage mat. They're all working together for the same common goal, to get all your water towards your exit doors and get it out. The main thing about this text is it took out over wood-based sheathing. Those that know the code out there, you know it was only applying to stucco going over wood-based sheathing, but now that's been taken out. So that's a big change. Now there is some geographical implications of this. Okay, so yeah, they had a map on here. This map was by the International Energy Conservation Code, and so you could see they broke it up into areas: moist, dry, and marine. So this marine is just this little section out here along the west coast, right along the ocean. You got that there. Then you got this big area of dry area that's broken Denver in half and Texas in half. And over here where the majority of the population is, that is going to be the moist area out there. Okay, so that's the areas that they broke it in. Like I said earlier, there are geographical difference when it comes to lath and plaster. This map is also indicating that as well. All right, so let's talk about the first one. We're talking about the dry climates. Okay, so it's got to comply with one of these two. I'll just break it down simply for you. But to point out a couple things, back when I was in the trade, we would buy the double paper that was already doubled up. So we just run one roll with the doubled up paper, so we get both papers at the same time. But look at what they're saying now. They're saying the individual layers shall be installed independently, such that each layer provides separate continuous planes. So now you got to do it twice, right? So that's one big thing there. And then this other one, you could comply with a foam plastic insulation like an Armax or something like that. So those are the differences there in the dry. Okay, but what happens when we get to the moist and the marine? Well, we've got to comply with those first two, like we just read off. You got to comply with those, but you also have to have a minimum drainage efficiency of 90%, and this is in a 3/8 space. Okay, so basically they're talking about drainage mats there. So they're talking about it over here in the marine area and over here in the moist area over here too. So big chunk of the country will have to comply with this going forward. Again, if you're a builder, I'm going to point out two things on this slide. One to be careful and one to also educate you on too. So the builders, contractors must update installation practices. You got to be in mind of this. Don't let it be used against you. Be caught up to that. Make sure that all your material is going to comply with the ASTMs with this. Big one, number 3, make sure that your flashing is working towards your goal of water drainage goals. So make sure they're working together. But here's a big one right here. So take some relief in here. State and local adoption will vary. You may be working in an area that they're already doing this. You may be working in another area, they're not touching this at all. So just be aware of it. Ask around, because the worst thing that can happen is you assume it's not there, you build it, and then something happens, it leaks, a consultant comes out and says, whoa, you didn't comply with any of the International Building Code changes. And so you might be stuck that way too. But just do your homework there. I'm not saying everybody is doing this right now, but just do your homework to make sure. Now, if you want more information on this, I'll leave this up for a second. You can take a picture of that. And just recently, in the last couple months, AWCI put this stucco and drainage planes. Again, we're talking about the code changes, introducing drainage mat into the system. So it's a more detailed document on the ins and outs of that as well. You've heard of the pencil test. So for these next few, I'm going to go ahead and kind of do the pencil test with you guys and also tell you stories about this. But when it comes to construction defects. So this was a situation that I would run into sometimes. Let's say that this right here is, let's say it's a 2-story house, and this is a balcony out here. And below this balcony is living space. Let's say it's a living room down there. So in essence, this balcony is now a roof. Okay, and what would happen typically is you'd have your waterproofer come out here, plywood down here below the topping, and they would take that waterproofing all the way up here, right? And there. And then I got my topping on there. And then right here, this 2 inches, this is by code, that the stucco's got to start 2 inches above hardscape. And what would happen a lot of times is this area right here, the waterproofing would be exposed. Well, the thing about that waterproofing, it doesn't have any UV protection. So what would happen is over time, it would get wet, get hot, and eventually it would blister. And when it blistered, water could then get behind the waterproofing. Now it's behind the waterproofing, and it's going to get down in your plywood or whatever your framing is down here. And now you're going to make it into the interior side just because of this little section right here was not protected. Okay, so what's one thing you could do about that? Well, you could put flashing on there. Now, here's the question. Are flashing elements designed to drain water? We know that question, that flashing requirements are designed to put water towards the exterior, right? So that's what our goal is. But is this flashing doing that? What this flashing is actually doing is protecting the waterproofing that is exposed in that 2-inch section. So I believe this is a gray area because the flashing is not really redirecting the water. It's just protecting your waterproofing. Your waterproofing back there. But I do think it's a good point that a stucco contractor could be tied into this. It really had nothing to do with it. Their work started above here. This was the waterproofing down here. So they're separate, 2 separate trades. But again, this is why pre-con is so important to bridge these types of gaps. Again, back to the stucco one. I won't go on much here because we've talked about it before, but your goal, your common goal, when you're looking at that detail, okay, I got my water here. Where's my exit? Oh, got an exit here, got an exit here, and there's no ways for water to get back here. That's our goal. As long as your detail does that, you're fine. Same thing here. Always treat each cladding separately. So there's sometimes on a job you might have 5 different claddings. You might have hardy, you might have stone, you might have stucco, you might have glass. As a general rule, keep every panel separately. And at the weep where any stucco terminates, always make sure that you're wicking that water away from the next cladding. Don't have that water go behind the next cladding. Kick it out. Keep everything separated. And again, this thing is doing the same thing. I got my flashing here, and I got my weep screed here, and I got my exit point right here and right here. I know I'm taking care of all my points there. What about when it comes to a expansion joint? We want to do the same thing. Now you notice there's no sealant in here. We don't want to have sealant in there because when this comes out, I'm dropping water right here. I want that water to be able to get out. Okay, so we don't really want any sealant on an expansion joint. Everything is properly shiplapped. This accessory is being ran the same time the water resistant barriers are ran, and this way I could properly shiplap everything in. If all your water resistant barriers up and now you're going to start putting in your trims, you're going to be at a disadvantage. You need to put a lot of your stucco accessories in with your water resistant barriers at the same time so they're properly shiplapped. All right, this is earlier I showed an image of this, and I showed that short flange casing bead here with holes in it. What we want to do here is have a longer leg here with no perforations. Now we know that water could wick around the paper, and if you got perforations, you're going to get water in there. So how do we seal up that? Well, one way to do that is take a peel and stick, self-adhere flashing, run it on the metal here, then overlap your paper. The paper's right here. Overlap your paper, and now you can bring your drainage mat into there. But what that's going to do is it's going to protect this vulnerable edge from water wicking around right there. It's going to seal it up. Again, water could get in there. What we're trying to do is minimize the water that gets in there and open up the exit doors. Same thing here, very basic. Okay, so we're talking about drainage mats here. I believe that the stucco accessories should always encapsulate the full system. Okay, what do I mean by that? So my leg is coming all the way back here, my attachment leg for my weep. This way it's going up against the substrate. And then this ground is probably going to be an inch and an eighth, an inch and a quarter to make sure I took care of my drainage mat. I'm forcing my water out through those holes right here, and my water get out. But I have also seen where they'll put a stucco accessory on top of the drainage mat, on top like here. What do you think is going to happen here when I take that nail and I screw it off? I'm gonna crush it. And if we're looking at this thing like an exit door, when I do that, I've got that water flowing, and now it gets behind that stucco weep screed, and now it's slow to get out. It's like I just propped open my exit door. I didn't open it wide open, I just propped it open, and now the water is really slow to get out. So you want to maximize that flow, encapsulate it, so all that drainage mat, all that water in there will direct it right into a hole, and there's no way to back it up. Remember, you got two exit points here. You got this one, and you've got this one. So you got plenty of places for the water to get out. You're not crushing it. The other thing, if you're an installer, once you put a stucco accessory over a drainage mat, how do you keep that straight? I mean, that's just one more thing an installer is going to have to deal with. Same thing on, we were talking about drainage points earlier. Okay, so let's picture you've got a 50-foot high wall, and it's load bearing. So there's no big need for an expansion joint, but you don't want the water that gets into, let's say on the top floor, to have to come all the way down to the bottom floor to wick out. Because just picture it, you pick up more and accumulate more and more water as you're going down. But if I'm going to minimize my water in my system, what I want to do is redirect that water out in every floor. So this is a great way, put this every floor line. And what that's going to do is going to force that water out here, here, and out. I see too many times, well, they'll just put a control joint over the water resistant barrier, and now, believe it or not, the water is going behind your control joint. Well, what happens there? Well, it gets bunched up at the control joint, and it's slow to get out. Then it moves down to the next floor, bunches up, slow to get out. That's what happened on those couple jobs that I showed you. So incorporating drainage points is a big way of doing this. And that wraps it up. That was my last slide there. So I'll open it up to anybody for any questions.
Yes, there are a couple coming in here. Can you touch on considerations for stucco on block?
Stucco on block. Yeah, that is a little bit different. Most of the fundamentals we were talking about here is to get the water out and drainage points and drainage planes. With stucco on block, there's a few, you don't have to deal with as much on the water infiltration part. So, you know, you got skim coats, you got lath, there's a lot of different ways to do that. There's a lot of regional practices with that as well. So I would step away from that question. My email would be up there and we could talk offline on that, but I know there's a lot of different thoughts on that. And I don't have a strong opinion either way, but I'd love to talk with you more if you'd like to reach out to me.
So you noted that cracks should be minimized rather than eliminated. What size of crack is considered permissible?
Great question. I knew that question was going to come in. Okay. The reason why I was pointing this out, because when I was a consultant, any kind of crack, sometimes I'd get called out. And that's the million-dollar question. What kind of crack is too big? Where is it coming from? So for me, these were the things that I would do. If I saw a large crack, I'm going to be looking, is the substrate able to move? And if I fix it and the substrate still moves, it's just going to come back. So each crack you have to look at a little bit differently. Now, incidental hairline cracks, they're not going to do much of anything. One of the reasons why I touched on drainage points so much is because let's say I got a few cracks in there and I got a little bit of water in there, but when it came down to my drainage point, I got that water out, it's not going to cause any damage. That's fine. The water resistant barrier is there for a reason. It is to protect it, but it just doesn't like to be overloaded. So as long as I get that water out, I'm fine. Stucco is going to crack. I know there's gauges that you could do. The stucco cracks that I think are too much are the cracks that have something going on with the substrate, something structurally going on. Those are too much. But minimize cracking, minimal cracking, typically, if it's well detailed, the water's still going to get out of there, and no harm, no foul. It's not going to create an issue. So I look at each one a little individually, see what's going on with it, see if it could be fixed, and see if it's doing any damage. Those are my 3 questions I would look for when I went to a project with cracks.
So this one's kind of long, so I'm going to try to do it in one shot for you, Don. Standards for lath and plaster and suspension framing system for exterior ceilings are available. However, there doesn't seem to be standards for interior ceiling with lath and plaster. What standards would apply on interior ceiling lath and plaster application?
That's a great question. I'm not sure on that one, but I could look into that one for you as well. I'm sure there's a code on it. The CTC Ceiling Group tackles those types of questions. So at AWCI, we have a codes and technical council, and one of those subcommittees is ceilings. And I believe that is one of the questions that they are working on. So feel free to partake in that group as well. And again, you could reach out to me offline. I could look into that question a little bit further for you.
Great. So putting the drain mat on top of the bottom casing will create a difference in thickness of stucco and promote cracking. How do you deal with that?
Say that one more time.
So putting the drain mat on top of the bottom casing will create a difference in thickness of stucco. How do you deal with that?
Oh, gotcha. Yes, you need a different ground size is what you're asking. So depending on where you're located, there's been different types of stucco systems that have come out. One system that came out was a 1-coat system. And in a 1-coat system, the grounds were 1 1/8 inches. Now, prior to that, the stucco manufacturers were just making the basic sizes, the 3/4 and the 7/8 for traditional stucco. But then they had to go to 1 3/8 inches because there was demand for it. Well, now that the code has changed and drainage mats are required in a lot of areas, the manufacturers, are making different ground sizes. So my recommendation is check with whatever manufacturer you're working with and see if they could change that ground size for you.
Okay. In section 1510.6.2 about the moist or marine climate, there's a requirement that minimum drainage efficiency should be 90%. Who is responsible for carrying out or paying for the testing to verify the 90% drainage efficiency?
Good question. So the manufacturer is going to have to supply that. So whatever drainage mat, they're going to have to supply that. Now, why that's such a good question to me is because I believe the way the test is ran is they just pour the water on top and 90% of that water has to make it through that drainage mat and get out. What I don't like about that is what happens when you stack a stucco system on it. And what happens if you start crushing it with stucco accessories? I don't think it's ran in a complete system. I think it's independently ran. So the manufacturer will make sure that they're in compliance. So look at it, make sure that that ASTM is referenced in their selling material. That means they tested it per that. But I do not believe, and I could be wrong, someone put in the comments if I'm wrong, I do not believe they run that 90% efficiency rate in a full stucco assembly, because think about all the different types of conditions that you have. Are they going to test it at an expansion joint, at a weep screed, above a window? That'd be quite a bit of testing. So I don't believe they're tested in a system like that.
Thank you. Last question here. Does lath have to be cut behind control joints, or can the lath be continuous across control joints?
Boy, that's a good one there. I'm sure there's a lot of people laughing right now about that question. We have to go by what the code says. And in the code, ASTM 1063, it says that it has to be cut. And I should probably leave it that way. I have a lot of personal feelings on that, but I'll tell you what they are. Basically, in California, we would always do a 2-piece expansion joint on the floor line, right? So we got a real expansion joint. And then typically in between that, on our control joints, we did not run the lath. We ran the lath all the way through and put the control joint on top. And what happened is, anytime there might have been cracking or something on that job, and you've got a building envelope consultant come in, they're going to go in, they're going to check that control joint and say, oh, the lath wasn't cut. That's what caused all the cracking. I personally don't believe that that's the case. I know I'm getting into some gray areas with people, but that's just my personal opinion. But I have to say what's in the code, and the code says that it has to be cut. So I have to stay in that lane.
All right, that concludes our Q&A session and presentation. Thanks so much, Don, for a great presentation. Thank you everyone for joining us. Don't forget to join us next month for our last part of the Limit Your Liability Series, fire stopping. And make sure to check out awci.org/events/calendar for more upcoming webinars. Thank you, everyone. See you next time.